The Big Bang Theory may have just been called into question by the James Webb Telescope, which would have been a major development in cosmology. This telescope, which was launched on Christmas Day in 2021, has surpassed all expectations and challenged our core assumptions about the cosmos. What secrets does it reveal, and what destiny does our universe face? Come investigate the galaxies and structures that the James Webb Telescope has just discovered. Looking back more than 13 billion years, we get a glimpse of a young cosmos that many scientists think came from the Big Bang. Different viewpoints on the origin of the universe are provided by alternate hypotheses, such as the bouncing cosmology and the steady-state cosmos. According to the plasma or electric universe concept, plasma plays a part in cosmic processes that affect how celestial bodies develop. Even though the Big Bang Theory is widely accepted, several of its predictions are called into question by new evidence. Leading the charge to collect this data is NASA's James Webb Space Telescope, which was created to reveal the secrets of the cosmos. In just 1 year of operation, its unmatched vision has amazed scientists by unveiling ancient galaxies that contradict our prior knowledge. For example, astronomer Rohan now discovered a galaxy within 300 million years after the Big Bang, which was a revolutionary discovery from his home. This finding, known as Glass C13, generated excitement throughout the world and demonstrated the telescope's capacity to solve cosmic riddles. The James Webb Telescope, cooled to almost absolute zero and located far from Earth's interference, is ready to reveal the mysteries of cosmic dawn. By examining old galaxies, researchers hope to validate current theories or create new ones that could provide insight into dark matter, dark energy, and the complex relationships that exist in the universe. Early views from the telescope have already surprised scientists by identifying galaxies that are older, bigger, and brighter than expected. Theorists and onlookers alike are rushing to investigate the consequences of this surprising discovery because it has inspired excitement and a sense of urgency. The James Webb Telescope's discovery of abnormally mature early galaxies contradicts our conventional picture of the universe and calls into doubt the accuracy of the initial observations. These discoveries could fundamentally alter our understanding of cosmic history, affecting not just far-off ages and galaxies, but also our place in the Milky Way. JWST scientist Marek McCarran highlights that these devices are not meant to validate paradigms, but to question them. The telescope's mission is to push limits and possibly disprove accepted beliefs, demonstrating a dedication to exploration and learning. In 1985, the Space Telescope Science Institute created the foundation for JWST's groundbreaking capabilities. Visionary astronomers like Thalinger and Ricardo Giacone realized at the height of the Hubble Space Telescope's dominance that it was necessary to imagine a replacement that could get past its shortcomings. JWST was developed in response to Hubble's incapacity to view infrared light, which is essential for researching distant galaxies. JWST's technological innovations, including as its large mirror and advanced sun shield, allow it to examine dim celestial objects with previously unheard-of clarity and sensitivity. It is outfitted with a giant mirror that is tailored for catching infrared radiation. The GRIM Lens Amplified Survey from Space and the Cosmic Evolution Early Release Science Survey, which sought to investigate galaxies in the early cosmos, tested its capabilities. Early observations from the telescope, however, exceeded expectations and revealed very distant galaxies far earlier than expected. These early galaxies finding disproves astronomers' assumptions and highlights how revolutionary JWST can be in changing how we perceive the universe. Notwithstanding the surprises, the telescope's capacity to obtain vital information and take comprehensive pictures opens up new possibilities for space research and discoveries. Astronomers have been shocked by the early development of mature galaxies discovered by the James Webb Telescope, which has defied predictions and called into question our knowledge of cosmic evolution. At first, scientists expected very far-off galaxies to emerge after several cycles of data from different programs. To their astonishment, though, these galaxies were present from the start. 2015 saw the discovery of GNZ11, the previous record holder for the most distant known galaxy, at a redshift of 11, which corresponds to a cosmic age of about 400 million years. But the first data from the GLASS program showed Glass Z13, which had a redshift of 13, making it about 70 million years older. This surprising discovery cast doubt on pre-existing hypotheses by suggesting a galaxy that is extraordinarily huge and luminous. Only 180 million years after the Big Bang, galaxy candidates with estimated redshifts as high as 20 were revealed by later discoveries from programs like Sears and Glass. Even more astonishing is the fact that some of these galaxies have disk-like structures, which is an unusual occurrence at this early stage of cosmic history. The conventional lambda cold dark matter model, which explains the development of the universe and the function of dark energy and dark matter, predicts that these huge and quick galaxy formations will occur. The model's prediction of a gradual and systematic process is called into question by the appearance of such massive galaxies. Even in the best of circumstances, galaxies of this magnitude wouldn't emerge so soon after the Big Bang, according to cosmologists like Michael Bow and Cullen, indicating a gap in our knowledge of cosmic evolution. Even while our knowledge of what happened after the Big Bang has advanced significantly, the time leading up to it is still mostly unknown. Important new information from follow-up studies of Glass Z13 with Chile's Atacama Large Millimeter Array suggests that dust may not be blocking the galaxy as first thought. But the difficulties ALMA had finding the galaxy show how difficult it is to validate James Webb Telescope observations. Researchers are re-evaluating their knowledge of cosmic evolution in light of these findings, facing the prospect that current models may require adjustment. Our basic assumptions about the universe's birth and evolution have been re-examined in light of the James Webb Telescope's revolutionary observations, which provide a window into the universe's early history. One controversial theory that is making the rounds in the scientific world is modified Newtonian dynamics, which casts doubt on the existence of dark matter. According to Mond, the gravitational effects ascribed to dark matter may actually be large-scale variations in gravity. Some scientists, like Type A, are still doubtful of Mond's ability to explain phenomena, while others, like Moore, endorse this theory and hypothesize that JWST findings might support it. Dark matter and dark energy, which account for around 95% of the universe's mass and energy, are a major puzzle in contemporary physics. Although we have never observed it directly, dark matter in particular appears to have an impact on how galaxies move. It would be one of the greatest scientific discoveries if the spacecraft had discovered a new force associated with dark matter. Another theory is that the spaceship has reached a region of space where the standard rules of physics don't apply. Although this seems odd, some physics theories, like a string theory, imply that it is feasible. String theory suggests that there are microscopic vibrating strings in higher dimensions in an attempt to relate gravity to the small-scale realm of quantum physics. These threads may act in ways that alter the known forces of gravity and electromagnetism in extreme locations. The principles of physics themselves may be subject to revision as we explore the cosmos. How physics could be rewritten by Voyager 1. Although string theory has not yet been tested, it is plausible that different regions of the universe could exhibit distinct behaviors. If the spacecraft is indeed at such a location, it may provide us with important information that either confirms or refutes these broad theories, which could alter our understanding of the cosmos and possibly uncover new physics laws. Questions concerning the future of space exploration are also brought up by the discovery. With technology from decades ago, the spaceship was not designed to investigate the cosmos, much less unexpected forces in deep space. Any new information it transmits must be thoroughly examined and contrasted with pre-existing hypotheses. New missions created especially to investigate such events may be inspired if this force proves to be significant and real. Future spacecraft could provide us with more accurate data by venturing farther into space, perhaps equipped with sophisticated quantum sensors. These still under development sensors may aid in our deeper understanding of electromagnetic and gravitational forces and may potentially provide hints regarding the distribution of dark matter or other unidentified energy. We have learned a great deal about the outer planets and the heliosphere, the outermost region of our solar system, from the spacecraft for more than 40 years. It is now entering regions of the interstellar medium, the enormous expanse outside our solar system, about which scientists know very little. Not only is the new data from the spacecraft unexpected, but it also raises questions about certain fundamental theories about space and the cosmos by pointing to cosmic forces and phenomena that we still don't fully comprehend. Whether this unidentified force represents a novel aspect of the interstellar medium itself is one of the main questions that scientists are posing. The data from the spacecraft indicates that this medium may be far more complex than we now know, which is a mixture of gas, dust, cosmic rays, and magnetic fields. Rather than being uniformly distributed, there may be tumultuous regions, peculiar magnetic fields, or even regions where unidentified particles exhibit hitherto unobserved behaviors. However, this isn't even the most peculiar aspect. The spacecraft is currently probing the area beyond the heliopause, which is more than just a silent void. It contains remnants of faraway galaxies' light and matter, stellar winds from nearby stars, and stuff from long-gone stars. It's possible that the spacecraft found evidence of interactions between this interstellar material and the aftereffects of our own sun, exposing previously unobserved dynamics. These peculiarities might manifest as slight variations in the density of particles in space, changes in magnetic fields, or perhaps entirely new types of matter and energy. Such variations have the potential to alter our understanding of the Milky Way, our galaxy, and beyond if they are widespread. The possibility that the spacecraft may have discovered something connected to dark energy is another perplexing theory. One of science's greatest mysteries is dark energy, which is believed to be the cause of the universe's increasing expansion. Since we haven't been able to detect or observe dark energy directly, despite the fact that it is thought to exist everywhere, little is known about its characteristics. The spacecraft may have entered a detectable region of dark energy, which might provide us with important clues about the behavior of this enigmatic force and help us solve one of the universe's greatest mysteries. One possibility could be that the spacecraft has entered an area where dark energy effects are more pronounced. Even though scientists think dark energy is dispersed equally throughout space, its effects might be more apparent in some locations, particularly those that are far from big objects. Dark energy may be subtly influencing the spacecraft's speed or direction once it entered one of these zones, currently distant from any major planets or stars. If this is true, it would be a revolutionary finding that connects the universe's expansion to the motions of its objects. However, what if the spacecraft has discovered evidence of a fifth force of nature? That would be the most thrilling finding to far. The strong nuclear force, the weak nuclear force, gravity, and electromagnetism are the four fundamental forces that scientists currently understand. There may be more forces, though, that we haven't been able to identify on Earth, as some scientists have long hypothesized. It could alter our understanding of physics if the spacecraft is being affected by a brand new, unidentified force. Far from the other powerful forces we are accustomed to, this new force may only manifest itself in the great emptiness of space. It might be causing the odd data the spacecraft is detecting by interacting with interstellar medium particles in ways we haven't anticipated. Finding such a force could help us understand dark matter, the invisible material that makes up the majority of the cosmos, and provide us with fresh insights into the behavior of matter and energy on the biggest scales. Whether the spacecraft has discovered a new particle is an intriguing subject when discussing galaxies or the structure of the cosmos. All of the known particles and their interactions are listed in the current particle physics model. However, it has its limitations. It does not, for instance, explain dark matter or relate gravity to quantum physics. The spacecraft has returned some odd data that may indicate it has discovered particles that defy our current understanding, such as the speculative axions, which could be a component of dark matter. If axions are genuine, they would be very hard to detect because they would be incredibly faint and wouldn't interact much with ordinary stuff. As we explore previously unexplored regions of space, new surprises await.